So dear students, welcome back. Let us think about the properties of Fourier transform, and let us take the second property of the Fourier transform, that is time shifting property. Here the time shifting property states that if the Fourier transform of x of t is equal to x of omega, then the Fourier transform of x of t minus t0 will be equal to e power minus j omega t0 into x of omega. So we can see here x of t is our input signal and the time shifted version of x of t is denoted as x of t minus t0. So our input signal x of t and the time shifted format that is x of t minus t0. Okay, x of t minus t0 or x of t plus t0. ഇതിനെയാണ് നമ്മൾ time shifted signal എന്ന് പറയുന്നത്. അതുകൊണ്ട് here we have considered x of t minus t0. നമ്മൾ എടുത്തിരിക്കുന്നത് x of t minus t0 ആണ്. So let us think about the proof of this property. The Fourier transform of x of t minus t0 will be equal to, as per the definition, integral minus infinity to infinity x of t minus t0 into e raised to minus j omega t dt. Okay, ഇവിടെ നമ്മൾ ഈ Fourier transform definition ആണ് consider ചെയ്യുന്നത്. Integral minus infinity to infinity, our input signal is x1 of t. Say if the signal is x1 of t, then that is to be taken here into e raised to minus j omega t dt, that is x1 of omega. Okay, so ആ ഒരു ഡെഫിനിഷന്റെ ആ ഒരു ബേസിസിൽ അതിന്റെ ഫോർമാറ്റിൽ നമ്മൾ ഇതിനെ എഴുതുക. So the input signal here is x of t minus t0, so that is the Fourier transform will be equal to integral x of t minus t0 e raised to minus j omega t dt. So ഇവിടെ here we have to consider t minus t0 as p. Okay, t minus t0 is equal to p, so that you can see t minus t0 is equal to p, then t is equal to p plus t0. Okay, again if you are differentiating it, then the left side, that is dt, will be equal to dp, and the differential of t0 will be equal to 0, because t0 is a constant. Here t0 is taken as a constant. Then if we find the derivative of t0 with respect to p, then that will be equal to 0. Okay, so here dt is equal to dp. We all know about it. So the Fourier transform of x of t minus t0, now integral minus infinity to infinity x of t minus t0 ക്ക് പകരം നമ്മൾ p ഇട്ടു, e raised to minus j omega, t ക്ക് പകരം we have put p plus t0. Okay, p plus t0, and dt ക്ക് പകരം we have put dp. Okay, so ഇവിടെ e power minus j omega p plus t0 എന്നുള്ള ഈ ടേം, second term, that is of the form e raised to a into b plus c. Okay, e power a into b plus c. So a into b plus c എന്ന് പറയുമ്പോൾ എന്താണ് ab plus ac. So that is nothing but e power e raised to ab plus ac. That will be equal to what? E raised to ab into e raised to ac ആണ് കേട്ടോ. e raised to ab plus e raised to ac അല്ല, e raised to ab into e raised to ac. So this one will be e raised to minus j omega p plus t0 എന്ന് പറയുമ്പോൾ e raised to minus j omega p into e raised to minus j omega t0. Okay, so e raised to minus j omega p into e raised to minus j omega t0. ഇതിനകത്ത് here the second term here, e raised to minus j omega t0 is in fact a constant. So here that is taken outside. So what remains here? Integral minus infinity to infinity. So integral minus infinity to infinity. You can see here integral minus infinity to infinity. Let us take it integral minus infinity to infinity. Just a second. Integral minus infinity to infinity x of p e raised to minus j omega p dp. So this term e raised to minus j omega t0 constant ആണ്, that is taken outside. So here, as per the definition of Fourier transform, x of p, integral x of p e raised to minus j omega p dp is nothing but x of omega. Okay, this is x of omega. So this term will become, this one will become e raised to minus j omega t0 into x of omega. So that is the Fourier transform of x of t minus t0. That is the time shifted signal, input signal x of t. So the Fourier transform of x of t minus t0 is e raised to minus j omega t0 into x of omega, where x of omega is the Fourier transform of x of t. Okay, x of omega is the Fourier transform of x of t. That's all about it. Thank you.